The discovery of an interstellar object moving toward the inner regions of our solar system has once again ignited widespread excitement and debate within the astronomical community. Objects originating from outside our solar system are exceedingly rare to observe, and each confirmed detection represents a unique scientific opportunity. Until recently, only 2 such visitors had been identified, making this newly observed object, designated 3I/Atlas, only the third known interstellar object ever detected passing through our cosmic neighborhood. Its appearance has prompted intense observation, discussion, and speculation, as scientists attempt to understand its origin, composition, and behavior. Because these objects are not bound by the sun's gravity in the same way as planets, asteroids, or comets native to our system, they carry with them clues about distant star systems and environments far beyond our reach. From the moment 3I/Atlas was identified, it stood out as unusual. Early observations suggested that it was traveling at a velocity significantly higher than what astronomers would typically expect from objects formed within the solar system. Its trajectory indicated that it was not orbiting the sun, but instead passing through on a hyperbolic path, a key hallmark of interstellar origin. While this alone was enough to spark scientific interest, further data revealed additional anomalies. The object appeared to have an unexpected shape and behavior, prompting some researchers to question whether conventional explanations, such as a comet or asteroid, were sufficient to describe it. Among those voicing a more provocative interpretation was Avi Loeb, a well-known and highly accomplished astronomer from Harvard University. Loeb has gained public attention in recent years for his willingness to consider unconventional hypotheses when standard models struggle to explain observational data. Early in the discussion surrounding 3I/Atlas, he suggested that the object could potentially be artificial in origin, possibly even a form of extraterrestrial technology. This suggestion was not made lightly, but rather based on a combination of observed characteristics, including its shape, speed, and apparent lack of typical cometary features. While many astronomers urged caution and favored more conservative explanations, Loeb argued that dismissing extraordinary possibilities without thorough investigation would be scientifically irresponsible. As 3I/Atlas continued its journey toward the inner solar system, more detailed observations became possible. One of the most intriguing developments was the detection of light seemingly emanating from the object itself. Unlike most small bodies in space, which are visible only because they reflect sunlight, this light appeared to be generated by the object rather than simply reflected. This raised further questions about the underlying mechanism producing the illumination. In typical comets, increased brightness is often explained by outgassing, as ice sublimates and releases gas and dust when heated by the sun. However, in this case, the observations did not align neatly with that explanation. Loeb addressed these issues in a detailed blog post, where he outlined his reasoning for why he believed 3I/Atlas was unlikely to be a conventional comet. One of his key arguments centered on the absence of a visible cometary tail. Comets are known for their distinctive tails, which form as solar radiation pushes dust and gas away from the nucleus, creating a luminous trail pointing away from the sun. In observations of 3I/Atlas, however, there was no clear evidence of such a tail, even though the object appeared to be brightening. According to Loeb, this lack of a tail challenged the assumption that outgassing was responsible for the observed light. He further explained that if the object were a comet, one would expect to see specific signatures associated with the release of volatile materials, including changes in brightness and the formation of surrounding clouds of dust or gas. The data collected so far did not conclusively show these features. Instead, the object's behavior suggested a more controlled or uniform source of illumination, which, in Loeb's view, opened the door to alternative explanations. He proposed 2 main possibilities, one being that the object could be a fragment of exotic astrophysical origin, such as debris from a supernova, and the other being that it could represent some form of technologically powered craft. While Loeb acknowledged that both possibilities would be extraordinary, he expressed skepticism about the likelihood of the supernova fragment hypothesis. He argued that the probability of such material traveling intact across interstellar distances and entering our solar system in this manner was extremely low. By contrast, he suggested that an object powered by nuclear energy, potentially for propulsion or other functions, could more plausibly account for the observed light and motion. This line of reasoning naturally led to speculation about extraterrestrial intelligence, a topic that remains controversial but deeply fascinating. It is important to note that Loeb's ideas have been met with significant pushback from many in the scientific community. Critics argue that extraordinary claims require extraordinary evidence, and that unusual observations can often be explained by natural processes that are not yet fully understood. They caution against jumping to conclusions about artificial origin when simpler explanations may still be viable. Nonetheless, even Loeb's critics generally agree that 3I/Atlas is an unusual object worthy of close study, regardless of its ultimate nature. Despite the controversy surrounding his claims, Loeb remains a respected figure in astronomy, with a long history of peer-reviewed research and leadership in the field. His willingness to explore unconventional ideas has made him a polarizing but influential voice. In the case of 3I/Atlas, he has emphasized the importance of gathering as much high-quality data as possible before drawing firm conclusions. To that end, he has advocated for the use of existing space-based assets to observe the object during key moments in its trajectory. One particularly promising opportunity will occur when 3I/Atlas passes relatively close to Mars in October 2025. During this time, Loeb has encouraged NASA to utilize the Mars Reconnaissance Orbiter, specifically its HiRISE camera, to capture detailed images of the object. HiRISE is capable of extremely high-resolution imaging and has previously been used to study asteroids, comets, and surface features on Mars with remarkable clarity. According to Loeb, the team responsible for the camera responded positively to his suggestion, indicating a willingness to attempt observations if conditions allow. Such observations could prove invaluable. High-resolution images and additional data could help determine the object's shape, rotation, surface properties, and any changes in brightness or structure over time. These details would provide crucial clues about whether 3I/Atlas is a natural object shaped by unfamiliar physical processes or something far more unusual. Even if the alien spacecraft hypothesis is ultimately ruled out, the data collected would still represent a significant contribution to our understanding of interstellar objects. Regardless of the outcome, the study of 3I/Atlas highlights the evolving nature of modern astronomy. Advances in detection technology have made it increasingly likely that more interstellar visitors will be discovered in the future. Each one will bring new surprises and challenges, forcing scientists to refine existing models and, at times, confront the limits of current knowledge. The debate surrounding this object also underscores the importance of maintaining a balance between healthy skepticism and open-minded inquiry. Whether 3I/Atlas turns out to be a strange comet, an exotic natural fragment, or something entirely unexpected, its passage through our solar system represents a rare and fleeting opportunity. For Loeb and many others, it serves as a reminder that the universe is vast, complex, and still full of mysteries waiting to be explored. The attention focused on this object ensures that it will be studied in detail for years to come, and the lessons learned from it may shape how scientists approach future discoveries. In the end, the true value of 3I/Atlas may lie not in confirming any single hypothesis, but in expanding our understanding of what is possible in the cosmos.